Hello, geometry students. This lesson practice is going to feel great compared to the marathon lesson practice we did last time. That last one went A through I. This one's just going to be A through D. Four relatively easy problems. We're going to be applying the distance formula here. The first one is going to be very, very, very easy. So let's get started. We need to find the distance AB. And we're just dealing with a number line. We're not dealing with two perpendicular number lines, which is a coordinate plane. When we're dealing with a number line, there's a special formula for distance. Distance equals the absolute value of A2 minus A1, and that's it. I'm just going to make sure that this 2 and this 1 are subscripts. And then I'm ready to plug in. It doesn't matter what I use for A2 or A1. Like, I'm just going to do this backwards from the way I would normally do this, just because it doesn't matter. So I'm going to put in -7 for A2, minus, I'm going to put in 5 for A1. -7 minus 5 is going to be -12. So it's going to be the absolute value of -12, which equals 12. All right, let's just verify that. From A to B, if I count the marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 units, so that's correct. All right, letter A, super easy. Let's move on to letter B. What is the distance between the points S and T over here? Well, I need to figure out what the coordinates are for the points first. S has coordinates -5, -3. And then Y, or T has points -2, -6. And then I'm going to use the distance formula. Distance equals the square root. I'm just going to use a semicolon and an open and ending parenthesis for my square root. I'm going to put my square root value in there of y2 minus y1 squared plus x2 minus x1 squared. I like doing y first and x second because there's other theorems that have y first by necessity. And if I just do y first all the time, I never mess that up. So it doesn't really matter. Remember, addition is commutative, so I can do the x's or the y's first. I'm going to stick with the formula and do the x's first here. So let's do that. It's going to be negative, let's see, the x is a -2 minus -5. Those are the x's, okay? I'm going to put the second -5 in parentheses so we know that it's a single term. I'm going to square that. And then it's going to be plus negative, let's see, y2 minus y1. I need to be consistent with what I'm using as y2. So -6 minus, and it's going to be -3. And that second term is squared as well, okay? Then I'm going to put that end parenthesis to show that that's what I'm taking the square root of. So this is going to equal the square root of -2 minus a -5 is -2 plus 5. That's going to be +3 squared. I could just, well, I'm just going to leave it as 3 squared. Plus -6 minus a -3. -6 minus a -3 is -6 plus 3. So it's going to be -3 squared. So it's going to be -3 squared, okay? So the square root of 3 squared plus -3 squared, well, both of those you're going to evaluate to 9, and 9 plus 9 is 18. So the answer to this is going to be the square root of 18, which is equal to the square root of 2 times the square root of 9. And the square root of 9 can be evaluated. So it's 3. So this is going to be 3 square root of 2 as an answer. 3 times the square root of 2. All right. Let's look at letter C. Oh, I'm supposed to round to the nearest hundredth, though. I forgot that step. So I do have to punch this into a calculator. 3 times the square root of 2 is 4.24. So I'm not going to keep it in exact form. I'm going to evaluate it to 4.24. And I don't have any units. I don't know what the units are in, but that's what the answer is going to be for B. All right. Letter C, find the distance between points 2, 3, and 2, 4. Well, they were really nice and just gave me the points instead of having to find them from the graph. So this is going to be the D equals the square root of x, we'll do x2 minus x1, so 2 minus 2. Oh, look at that. The x coordinates are the same. That means that the y coordinates are the only ones that are actually going to affect the distance, because there is no x dimension to this line segment. But I'm just going to continue with it. So square, we can still use the distance formula for this. It's just one of the terms in the distance formula is going to be 0, this first one. So let's see, that was x2 minus x1 plus y2 minus y1 squared. Well, y2 is negative 4 minus y1 is 3. And I'm going to take negative 4 minus 3 squared. And then it's the square root of that. So what this is going to evaluate to, the first term, 2 minus 2 is 0. 0 squared is 0. Plus negative 4 minus 3. Negative 4 minus 3 is negative 7. Negative 7 squared is 49. But I need to take the square root of that. So it's going to be the square root of 49. Let me make sure I got the right symbol there. The square root of 49. And the square root of 49 is simply 7. All right, now let's just look at that again. So notice that my x-coordinate is 2 for both points. And my y-coordinate for the first point is 3 above the x-axis. My y-coordinate for the second point is 4 below the y-axis. Does it make sense that the distance between the two is 7? If you draw out the 2 points and you just count the line straight down, it's not like ST, which was diagonal. This is a vertical line, and it's really easy for vertical or horizontal lines to figure out the distance just by graphing them and doing it by inspection. All right, letter D. In letter D, we're going to be working a real world problem. The peak of a mountain is located at the coordinate 120, 0. A hiker starts at the bottom of the trail at coordinate 0, 125. If each unit on the coordinate plane represents 10 meters, how far will the hiker walk if he gets to the peak, round to the nearest tenth? All right, so what we're going to do is we're going to take D equal to the square root, just like before, of, let's see, x2 minus x1, so 0 minus 120, and we have to take that quantity and square it, x2 minus x1 squared, plus y2 is 125 minus 0 squared, and then I'm going to take the square root of that sum of squares. Well, okay, so I have to use a calculator for this. 120 squared is 14,400. So the distance is going to equal the square root of 14,400 plus, here, let me put in my open parenthesis back here too. All right, 125 squared is 15,625. Okay. And then I need to take the sum of that number and 14,400, and I'm going to take the square root of that, and I get the answer D equals 173.28. But hold on, every coordinate was 10 meters. So what am I going to have to do? Well, I'm going to have to multiply this result by 10. And that's going to give me, so I'm just going to write a times 10 in here, equals 1,732.8. And let's see, 10 meters, so that's in meters. To multiply by 10 at the end would have been the same as multiplying each of these numbers by 10 at the beginning. And that's how you work this problem set. You are ready to use distance formula in solving problems. Go ahead and get started on 1 through 30.